Now let's understand the proof of the derivative of secant function. So let's state it first. When y is equal to secant x, or sec x for short, then the y dx is simply equal to sec x tan x. So we are going to investigate why this is true in this video tutorial. So keep in mind, secant function x is a reciprocal function and simply equals to 1 over cosine function of x. If that is the case, since f of x is equal to y and is equal to secant x, then f of x is still the same as 1 over this 1 over the cosine function of x. Now, we will be considering using the definition of derivative, which is first principle, to prove this out. First principle says that for any function, its derivative, the y dx, is simply equal to the limit as delta x, or change in x, or h, approaches 0 of f of x plus h minus f of x, all divided by h. Now the goal is to determine f of x plus h, since we have f of x already. Since f of x is 1 over cos x, then what would be f of x plus h? That's simply 1 divided by cosine x plus h, because what that means in essence is that wherever we see x in f of x, we should replace with x plus h. Perfect. Now we have everything we need. We can proceed on finding the derivative. So therefore, the y dx is equal to the limit, let me write that properly, the limit as h approaches 0, f of x plus h, that's 1 divided by cosine x plus h, and minus f of x is 1 over cosine x, then entirely we have a division of h. So our goal is to find a way to get rid of the h in order to have undefined function and substitute the limits given. So this is a compound fraction. Let's combine the fraction at the numerator first. So this is equal to the limit as h approaches 0. So let the LCM be cosine x plus h, cosine x. So let's have the division. Now cosine x plus h in this entire expression gives us cos x, and if we multiply by 1, we have cos x back, cosine x. Then we have the minus sign. Cosine x in this gives us cosine x plus h, and multiply by 1 gives us cosine x plus h. Good. Now, don't forget we still have division of h. Good. At this point, we can use the concept of keep, change, and flip. This is a fraction itself, and it's divided by another one. So that becomes the limit as h approaches 0 of cosine x minus cosine x plus h. Oops, what did I write? Minus cosine x plus h divided by cosine x plus h times cosine x, then multiply by 1 over h. So what I've done is I've turned this number line division into a regular, and at the same time I flip it, change it to product. And doing that, I will have to flip this one as well. Good. Okay? Perfect. Well, my mind said I have to make a clarification. Okay, this is just like divided by h. Divided by h. Okay? Now, the way it is, what we are going to do now is that we are going to keep this one again. Then we change the sign to product. Then we are going to turn this upside down. Okay? And end up with times 1 over h. Okay? You understand now? Perfect. Now, let's continue. Now we have the y dx to be equal to the limit as h approaches 0. Now we need to use some of our trigonometric identities to expand cosine x plus h. So we have cos x minus, to expand cos x plus h, we are using some of the compound angle formula. So the one we are going to consider using is that of the cosine. It says that the cosine of 2 angle A plus B is equal to the cosine of the first, cosine of the second, minus sine minus sine of the first, sine of the second. So instead, if it is subtraction that is here, so you just change this one to addition. Okay, they are opposite themselves. Okay, good. Now therefore, instead of cosine x plus h, we can have it as cosine x cosine h, then in the bracket minus sine x sine h. Okay, then divided by, okay, now don't forget we have cosine x plus h, cosine x times 1 over h. I've actually get rid of that, but it's still there. Okay, I hope you are not lost yet. This expression we're having right here is the expansion of cosine x plus h. Okay, we use some of the trigonometric identity to do that. Is that clear? Perfect. Now, continuing, we have the limit as h approaches 0 of cosine x. Now, let's distribute the minus cos x cos h. Okay, then minus times plus minus x plus sine x sine h, and entirely divided by cosine x plus h times cosine x times h. I multiply the h. Perfect. Now, first and foremost, I would like to get rid of cosine x out of this problem, because it really have no business with these entire expressions within the limits. So I'm taking it out of the limit, because the limit is such that it's h is with respect to h, but cosine x has no business with h. So we have 1 over cosine x multiplied by the limit as h approaches 0 of cosine x minus cosine x cos h, then plus sine x sine h. Good. Then we see a division of cosine x plus h times h. You know, the cosine x has left. Perfect. Now we can continue. We now have the y dx to be equal to the limit. Okay, we have taken something out of the limit. That's 1 over cosine x times the limit as h approaches 0. Now, for this one, let's factor out cosine x. Then we have cosine x, then the bracket will be 1 minus cos h. You know, after taking cosine x outside, we have 1. Outside, we have cos h. Perfect. Then divided by cosine x plus h times h. Then don't forget we have plus sine x sine h. Now what I would like to do next is that I would like to separate the cosine x plus h as well from this fraction, but it should still be within the limit because it has h term. So 1 over cos x times the limit as h approaches 0 of 1 over cosine x plus h times, okay, and it's going to multiply, times cosine x, and just put that cosine x, times 1 minus cos h, okay, then plus sine x sine h divided by h. Very good. So now, since limit of product is equal to product of limit, we have 1 over cosine x, just put that in bracket, then we have the limit as h approaches 0 of 1 over cosine x plus h, alright, then times the limit as h approaches 0 of cosine x times 1 minus cos h, then plus sine x sine h, then divided by h. Perfect. Now this is equal to 1 over cosine x. Now this entirely becomes 1 over cos h, because when we plug in 0 as h, we have 1 over cos x plus 0, which is cos x. So we have in the bracket 1 over cos x. Okay, this is cos x. Perfect. Times, now let's split this one as well. We are now the limit as h approaches 0. So I'm distributing h for this term and this term. Limit as h approaches 0 of cosine x multiplied by 1 minus cos h divided by h, then plus sine x sine h divided by h. Very good. Then we see the box bracket. Good. So therefore the y dx is now equals to 1 over cosine x times 1 over cos x, again, then multiply. Now since limits of addition is addition of limits right here, the limit of addition is addition of limits, we have times the limit as h approaches 0 of cos x times 1 minus cos h divided by h plus the limit as h approaches 0 of sine x sine h divided by h. Good. Therefore we have 2 brackets there. Perfect. Now the y dx is now equals to 1 over cos x and multiply by 1 over cos x again. Now the limit of this, you can see cosine x has no business with the limit. You can take it out. So cosine x, the limit as h approaches 0 of 1 minus cos h all divided by h plus also sine x has no business. You can take it out of the limit sine x multiplied by the limit as h approaches 0 of sine h over h. Good. Now this is equal to 1 over cos x times 1 over cos x, then multiply by cos x. Now you need to understand that the limit as h approaches 0 of 1 minus cos x cos h over h is simply 0. So times 0. You can confirm that with your calculator. Just type this entirely into your calculator, you should have 0. But make sure the calculator is in radian, or you yourself should be plugging in value that is approaching 0, like 0.000 something, into this expression and be dividing it. You see that you'll be ending up with 0 plus sine x times 1 also. You need to understand that the limit as h approaches 0 of sine h over h also gives us 1. Perfect. Now we have left it 1 over cos x times 1 over cos x. Okay, then multiply by, this is just sine x, sine x. Okay, then we're almost there. So therefore the y dx is now equals to 1 over cos x times 1 over cos x times sine x. This is equals to 1 over cos x times sine x over cos x. Now sine x over cos x is equal to tan x, and 1 over cos x is equal to sec x. So therefore we have sec x tan x, and this is how the derivative of sec x becomes sec x tan x. And I hope you find it helpful and understandable. Thank you. In our next video we're going to understand how to make use of this effectively in calculus problem. Now also keep in mind that this is the same as sine x over cosine squared x. They're actually the same. Thank you. See you in the next video. Bye for now.